So here I can see most of the question. It's all about doing the simplification at first and then finding the derivative. You will be able to do, right?
Oh, yes, ma'am. I finished exercise 5.3.
Okay, you have finished that also. Great. Okay. So yeah, let's continue. I wanted to leave it for you. Then if you have already done great, let's continue. So today we'll be discussing exponential and logarithmic function. Okay. So at first we will be talking about exponential function. Okay, exponential function, and then we'll be discussing logarithmic function. So what is exponential function? So exponential function is such a function which will grow, as the name says, which will grow exponentially. Okay, you will be giving a smaller x value and all of a sudden very big y value will start generating. Such function we are having, and that's called exponential function. Now before starting the discussion of exponential function, what exactly is exponential function? Previously you have seen this type of function, right? Y is equals to x square. Okay, here also
Yes.
we understand that when we'll be taking x, here also you can see when we'll be taking x as a let's say 1, when we'll be taking x as a 1, y will be 1. But when we'll be taking x as a 2, y will be 4, right?
Yes,
Right,
ma'am.
Fatima? When we'll be taking x as a 3, y will become 9, right? And when we'll be taking x as a 10, y will be, what will be the value of y?
100.
100. So can you see very smaller number we have taken for x, and y exponentially it has grown. Previously it was just increasing slowly, and we can see when we have taken x as a just 10, y became 100. When we will be taking x as a just 100, y will become 100 square. That means 10,000, right?
Yes.
Right. But this is polynomial function, right?
Yes, ma'am.
Right. This is polynomial function, and we also know the graph of this polynomial function looks like this, right? Right.
Yes.
This is also growing. Now there is a function which will grow much more faster than this type of polynomial function. Even if you are taking x to the power 4, x to the power 5, there is a function which will grow faster than this function, and that function is called exponential function. Okay, so exponential function will look like y is equals to a to the power x. Okay, it will look like a to the power x. Now question is y is equals to e to the power x, is it also exponential function? Oh yeah. Okay, this is also exponential function where this a is bigger than 1. Okay, we'll be taking a larger than 1. Now how exactly, like whenever we will be previously, whenever we have discussed any new specific function, first thing first, what how the function is defined. Okay, what exactly is the function, then what is the graph of the function, then what is the domain and what is the range, right? Fatima, these are the things which we need to know about any function, right?
Yes, ma'am.
Right, Fatima? Let's try making the graph. Okay, quickly we'll be making the graph. Any function which looks like y is equals to a to the power x, that is exponential function where a is bigger than 1. Now, if we will be taking one of the example of exponential function as a y is equals to 2 to the power x. Okay, this is one of the example of exponential function. Even if you will be taking y is equals to 3 to the power x, that is also exponential function. You will be taking y is equals to 10 to the power x, that is also exponential function. Okay,
Yes,
now
ma'am.
let's see how exactly the graph, like how exactly we are having the graph of this exponential function. So when x is when x is 1, y is, for this particular function, 2 to the power x. When x is 1, y is,
2,
yeah. When x is 2,
2,
y is, yes, exactly. When x is 2, y is,
4,
right? When x is 0, y is,
1,
yeah, it's 1. When x is, let's say 3, okay, y is
8,
8. Can we take negative values? Let's try taking negative numbers. When x is minus 1, y is,
1 by 2.
right, that is 0.5.
Yes.
Okay. When x is negative 2, y is,
1 by 4. So 0.25.
perfect. Okay. Let's try taking few more values. Then quick, we will be plotting the graph. When x is, it will be very small. Okay. Let's try plotting the graph with this. You can understand. We'll be taking more negative number like minus 3, minus 4. It will be very, very, very small number we will start getting, right? For y.
Yes.
Okay, so let's try plotting with this much of information. So first coordinate is 1, comma 2. Okay, let me write 1, 2, 3, 4, 5, 6, 7. Here minus 1, minus 2, minus 3. That's it. Here 1, 2, 3. Oh yeah, 8 is also there as a output. So here I'm making it. Okay, now let's locate the points. First coordinate is 1, 2, x is 1, y is 2. X is 1, y is 2. This is the point. Right, Fatima?
Yes, ma'am.
Next is x is 2, y is 4. So somewhere here. Right? Next is x is 0, y is 1. Somewhere here. Right? After
Yes.
that, x is minus 1 and y is in between 0 to 1. That is this. Somewhere here. Right?
Yes.
And x is minus 2. It is just over here. Right, Fatima?
Yes.
So this is how our graph is going. It will go like this, and when we will start taking negative number like minus 3, minus 4, minus 1, it will very, very, very smaller number, very smaller number, 0.0000 something as a y value you will start getting. It will feel like y is approaching 0 when you are taking x. When x is approaching negative infinity, y is approaching 0. Okay, this is how we'll be having the graph of exponential function which looks like y is equal equals to a to the power x, and this is the graph of y is equals to 2 to the power x. Even if we will be drawing the graph of y is equals to 3 to the power x, 4 to the power x, or maybe y is equals to e to the power x. E is just a number, it's like a pi. E is a Euler number and its value lie in between 2 to 3, 2 point something is the value for this e. Okay, so you can understand, if we can take anything to the power x, any number to the power x, that is called exponential function. So yeah, y is equals to e to the power x is also exponential function. Okay, and this is how we'll be having the graph of exponential function. Getting it, Fatima? And yeah, one
Yes,
more
ma'am.
thing, that even if we will draw the graph of y is equals to 3 to the power x, or maybe y is equals to 4 to the power x, or anything to the power x, if you will be taking x as a 0, y will be 1 only, right?
Yes,
Right? Okay. If y is
yes,
equals to anything to the power x, any number to the power x, if you will be taking x as a 0, obviously y will come out as a 1, right?
yes, ma'am.
That's why we say that exponential functions graph touches the y-axis at 0, comma. Is it clear, Fatima?
Yes,
Now one more thing you can notice from here, that this graph is steeper. This graph is steeper than the previous graph. This one is steeper than the previous graph. What is the meaning of steeper? It is like the previous graph was, this is the parabola we were having, and that was polynomial function which was growing, like it was also growing exponentially. We felt like that this function is growing in exponentially. If we will be taking x to the power 4, it will, like, for a small value of x, y will be huge, right?
yes, ma'am.
Right? but but our exponential functions graph is much more steeper than this graph. Okay, if you want me to show it, let me show it. The steeper means more towards the y-axis. Okay, you have seen whenever you go to water park, or maybe anywhere, in any park. Okay, so you must have seen rides and all. So if the ride looks like this, that means it is quite easier ride. If the ride is like this, it is also okay. But if the ride looks like this, it is very, like, adventurous, dangerous, whatever you say, right?
Yes,
Right? Why? Because here,
yes,
like,
ma'am.
you in uniform manner, x is increasing, y is increasing, x is increasing, y is increasing. For the other one also, it's quite steeper than the previous one, and this one is the most steeper over here. It's just like closer to y-axis, so it is most steeper. When you will start this type of staircase, if anyone will draw at home or anywhere, it will be very difficult to climb on this stair, right?
Yes, ma'am.
Okay, that's why this one is more steeper. Here this function is growing exponentially much more than the previous two functions graph. Okay, now, yeah, now what is the domain, what is the range we'll be discussing. Now let me show you these things over the graph also. Just a second. Just a second. this is the graph we are having. Fatima, see carefully. When I will just keep it like this, it will look like. Can you see? Can you see? The blue graph is steeper than the red graph.
Yes, ma'am.
Okay? That's why we say that this is in actual called exponential function. The previous one is polynomial function. Now the question is, I am removing the red one. This is the graph we are having, and this type of graph we have seen. When we plotted the graph, this is what we have also got. Here, if you want to check the point, if you want to check the point at which point the graph is touching the y-axis, can you see it is 0, 1?
Yes, ma'am.
And even though it looks like the blue line is touching the x-axis, no, it is not touching. Okay, if you will zoom, and you will see that is it exactly touching or what, you will find that no, it's not touching, it's just approaching, it is about to touch, but it is not touching. Okay,
Yes, ma'am.
it is about to touch, but it is here it looks like that. I need to zoom to show it to you, but actually it will just approach. When x will approach minus infinity, y will approach 0. Okay, so this is what we are having. Now the question is, what is the domain and what is the range? Now can you tell me, Fatima, what is the domain of exponential function and what is the range of exponential function?
Mm,
Yes,
real numbers?
yes, domain. You can see here, and while making the table also we have taken any x value. 0 also we have taken, positive also we have taken, negative also we have taken, we could have taken decimal number also, that is also okay. So any real number. Okay, domain is all real. Now what about
Yes,
the
ma'am.
range? What about the range? What will be the possible output? Yes, can you see the graph? The graph will give you the idea what is the possible y we are getting in the graph also. You can see, Fatima, the possible output. Is there any portion of graph towards the negative y?
No, ma'am.
So negative y excluded from the range, right?
Yes, ma'am.
Okay. So what can we say about the range of this particular function?
The zero.
0 to infinity. Now the question is, 0 will be included or not? So anytime y value will be 0, whatever you are going to take x, negative value, positive
No,
value, whatever, y will be 0?
no.
Never. So can we see that open interval 0 to infinity? That means it can be
Yes,
very, 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 very smaller number, but not 0. It will be 0 when x will be minus infinity, but that is not real life scenario, right?
yes, ma'am.
Okay, so we will be saying that the range of this particular function is open interval 0 to infinity, or the set of all positive real number excluding 0. Getting it? Getting it, Fatima?
Yes, ma'am.
Let's continue. So domain is all real number. This is R, and range is 0 to infinity. Is it okay?
Yes, ma'am.
Now let's continue. Now we are having, this was all about exponential function. We understood what is exponential function, right?
Yes, ma'am.
Now what is logarithmic function?
Mm.
Any function which looks like this, log, just log b base a. Okay. Now here, like the question is, what will be b? Is there any, okay, instead of b, let me take x over. Then we will be comfortable. Just a second. Yeah. Now we can understand here, input is x and output is y. Right, Fatima?
Yes, ma'am.
Okay, any function which is in this form is called logarithmic function. Now the question is there any criteria for x? Is there any criteria for a? Does a also matter? So let's see.
Mm.
If we'll be taking one example, that is log 2, and here base I'm taking 2 and x. Here also log x and here I'm taking base as a 2. So if for this particular case one, for case one, if we will be taking x as a 2, what will be the result, Fatima? What will be the result? Yes, log 2 base 2, result will be
4.
log 2 base 2 if the base and the number over here, if the base and along with the log whatever number is there, both are same, the result is 1. Do you know that?
Oh, yes, ma'am.
You know that, right? If we'll be taking here x
Yes.
is a 4, what will be the result?
Mm. 2.
Log 4 base 2, right? 4 can be written as 2 square, yes or no? Right, Fatima?
Yes, ma'am.
And this power will come in front. Do you know that? Okay, so we'll be discussing the property of logarithms over here in detail. At first, let's finish this exponential function, then we are coming to logarithmic function. In detail, we'll be discussing the property over here. Okay, then it will make sense to you that what exactly I'm trying to explain. So let's finish this exponential function today, because at one, like in one go, if I'll introduce everything, you will, there is a chance that you will end up getting it complete. Let's continue with exponential function. Okay, let's finish the exercise, the questions and everything, the basics, and then we will move to logarithmic function. Okay.
Yes, ma'am.
Yeah. I'll be explaining that one in detail. I'll introduce like all the properties. I'll be recalling all the properties. What exactly was the property of logarithm, and then we'll be starting the discussion. So yeah, let's continue with the derivative of exponential function. Okay, exponential function. This part is clear, Fatima.
Yes, ma'am.
Okay, so let's try understanding that if we will be having exponential function, then how to find the derivative of that. Okay, so the first question over here is differentiate. Still we'll be using chain rule over here, which you already know. Differentiate the following with respect to x. Okay, number one is if we are having e to the power x over sine x. We know how to do the derivative of this one by using u by v rule. Yes or no?
Yes, ma'am.
Let's do it. So what will be the derivative, Fatima?
Sin x into e raised to x minus e raised to x into cos x
Perfect.
divided by sin square x.
Perfect.
Yeah.
If we'll be having e raised to the power sine inverse x, let's find the derivative of this one with respect to x.
Um,
If this is y, divide dx will be
with is it e raised to x into root 1 minus x squared?
yes, e raised to the power e raised to sine inverse x into, we'll be doing this sine inverse x, that is 1 by under root 1 minus x square, and we are done, right?
Yes, ma'am.
Yeah, it's that simple. So here nothing new we are learning. Okay, you already know this concept, right, Fatima?
Yes, ma'am.
Only the question can be like one time we are doing the applying the chain rule, then one more time we are applying the chain rule. So what? You know this concept that until or unless we are done, we can keep on applying the chain rule, right?
Yes, ma'am.
So this one also you will be able to do e raised to the power x cube. Let's do the next one. If we are having y is equals to sine tan inverse e raised to the power minus x. Let's do this one together. Okay. So dy over dx will be what, Fatima?
Um, cos of tan inverse e raised to x.
Perfect. Then
Um, and then tan inverse 1 by 1 plus x.
perfect. 1 by 1 plus x square. Here x is this, right?
Yes.
And again we have to do the derivative of this one. What will be the derivative of this one? E raised to the power minus x derivative will be,
E raised to the
see. Then this is not x, this is minus x. So again that minus x we need to do, right?
yes.
That is derivative of minus x will be,
Minus 1.
let me explain it. First, this sign became cos, whatever was there. We are treating this complete, we are treating this complete as just x. So we need to do the derivative of that.
Yes, ma'am.
Okay. Then we did the derivative of that. It looks like tan inverse function. So 1 by 1 plus x square. Now we have treated this e to the power minus x as a x square. So we need to do the derivative of this e to the power minus x. We did the derivative of e to the power minus x, and it is e to the power, it looks like e to the power x. So we have applied the formula, it is just as it is, but it is not just x, it is minus x. So again we'll be doing the derivative of minus x. Yes or no, Fatima?
Yes, ma'am.
Is it crystal clear?
Yes, ma'am.
Okay, so this is how we will continue, and we are done. We are done. Just the minus sign which we are having, we will be writing it in front, and then we will try arranging everything a little bit, and then we will leave our answer as it is. Okay, so let's do that. Here we'll be having minus. This minus sign we are writing in front, and e to the power minus x we are writing in the numerator's part. In denominator we are having e to the power minus x whole square. Okay. In
Yes,
exponents
ma'am.
and powers chapter we have learned that if the same term, if the same base is having two powers, like if we are having a to the power m, and this power n can be written as a to the power m into n, can be.
Yes, ma'am.
Okay, so here also we can do the multiplication of the exponents, and it will be e to the power minus 2x. Yes or no?
Yes, ma'am.
Okay, 1 plus will remain as it is, and then cos of tan inverse e to the power minus x will remain as it is. Any conclusion, Fatima?
No, ma'am.
Let's continue. Log of cos e to the power x. If y is that, let's do dy by dx. Let's find the derivative with respect to x. So dy dx will be
Mm.
yes, Fatima, dy dx will be log x
One, one by cos e raised to x.
into
Mm. Minus sine e raised to x
into
into e raised to x.
yeah. We can write it like this: minus e raised to x is there, and sine e raised to x by cos e raised to x. We call it tan e raised to x. Okay. So even if and this question came in MCQ question part and the option is like that, we understand sine of whatever and cos of whatever can be written as tan of whatever the same, right?
Yes, ma'am.
Let's continue. Now the next question is, if we are having e raised to x plus e raised to the power x square plus dot e raised to the power x to the power 5. Okay, let's continue doing the derivative with respect to x. So this is y dy dx, this is y dy dx will be
E raised to x, e raised to
plus
x squared into 2x
2x e raised to x square, right? Plus
yes, plus 3x squared into e raised to x raised to 3
effect, then 4x cubed e raised to
plus
the
4.
power, and then confusion, Fatima.
5 raised to 4 and then e raised to x raised to 5.
Here, if the question is given like this, we understand e to the power x square is there, then e to the power x cube will be there, then x to the power 4 will be there, and then 5 is there. Okay, and we need to do the derivative of all. And since plus plus is there, so part by part we can do the derivative. Okay,
Yes,
if we are having the function as y is equals to under root e raised to the power root x. Let's do the derivative. Let's find d by dx.
Mm.
So at first it looks like under root x, right?
Yes, ma'am.
Okay. So when we have to do the derivative of root x, if we have to do the derivative of root x, we understand x to the power n formula we can apply, that is n x to the power n minus 1, right?
Yes, ma'am.
So this root x can be written as x to the power 1 by 2, and it will be n x to the power n minus 1, right?
Yes, ma'am.
And let's see over here only what exactly is the derivative of root x. So what are we going to get, Fatima? X to the power 1 by 2 minus 1 is what?
1 by root x.
Exactly. So can we say it is nothing but 1 by 2 root x?
Yes, ma'am.
Here x to the power 1 by 2 minus 1 is x to the power minus 1 by 2. That can go in the denominator along with the 2, right? So we realize that ddx of root x is this. Any confusion over here, Fatima?
No, ma'am.
Okay, so that means this can be written as 1 by 2 under root, the same thing, right?
Yes, ma'am.
And since we have treated this one as a x, we need to do the derivative of this one again. So what shall we do? The multiplication by chain rule.
Mm. E raised to root x. Mm.
Yes. Then
Into 1 by 2 root x.
and we are done. We are done, right? Right, Fatima?
Yes, ma'am.
We are done. Okay. So let's write it. The combined form 1 by 4 is there. The root x is there in the denominator, and this root part is also there. Okay, under root e to the power, but here and here same term are there. You can leave your answer like that for this particular question, but if this question is there in MCQ question, and if this option is not reflecting over there, that means we need to simplify it. So can you see in numerator part the same
Yes,
thing
ma'am.
is there without any root, and in the denominator a root is there, so we can cancel them, yes or no, and we can say a root will be remaining in the numerator. Can we say?
Yes. Yes, ma'am.
Getting it?
Yes, ma'am.
Let's continue. Now we are having log of log x y is, let's find d by dx, which will be
1 by log x. 1 by.
yeah. Okay, let's move cos x by log x.
Mm.
You
Log
can
x
apply
into minus 1.
this power x into minus x.
Minus cos x into 1 by x divided by log square x.
Okay. Yeah, this is how we'll be doing. So we are done with this exponential function. However, let me check if any different type of question is there which we can discuss over here. Just a second.
Yes.
If e to the power x plus e to the power y is equals to e to the power x plus y, okay, then prove that dy dx plus e to the power y minus x is equals to 0. Let's do it, Fatima.
Yes.
Yes, let's continue. E to the power x. Let's, what can be done over here, Fatima? Please tell me.
Mm, we differentiate both sides with respect to x.
Yeah. Just give me a second. Just a second.
Yeah.
Yeah, let's try finding dy over dx and let's see, are we going to get or we have to do any arrangement over here. Okay, so let's do it. E to the power x, derivative of that will be e to the power x, right?
Yes, ma'am.
Next one, e to the power y, derivative of that will be, Fatima.
E to the power y into dy by dx.
Perfect. Okay, implicit function we have already discussed. And on the other side, e to the power x plus y, the derivative of that will be
E to the power x plus y into 1 dx.
1 plus,
dy by dx.
correct? Okay, now here we have to prove something. Let's try finding dy by dx. Okay, if we will not get anything, like maybe we will get the proof over here only, or maybe we have to take dy dx from here and we have to substitute on the left hand side and then we will be getting the proof, right?
Yes.
Right. So whatever way we are doing, it's completely fine. In class, in your previous class, in class 11, class 10, you have done so many proofs and you understand that either we will be getting the proof directly from this expression or from here. If that we are not able to do, then from here we can collect what is dy dx, that we can go and substitute over here, and then we can do whatever simplification is possible. And if we are getting 0, then we will say that yeah, we are done with the proof, right?
Yes, ma'am.
Let's do it. Let's try doing it. So dy dx, if we will try collecting from here, what are we going to get? We can see this term is having d by dx. So e to the power y is having d by dx, and from the other side we will be getting one d by dx. That is, if this complete will get multiplied with the second term, that will be having d by dx, right? Right?
Yes, ma'am.
So we can write minus e to the power x plus y d by dx. Yes or no?
Yes, ma'am.
Is equals to e to the power x plus y minus Fatima. What will be there?
E to the power x.
Okay. Now we will be able to take out the common factor. Now the question is, what is the common factor over here, Fatima?
Mm, E to the power y.
Yes.
Into dy by dx.
Yes. What is the remaining?
Minus e x into dy.
Right?
Yes.
On the other side, what is the common factor?
E to the power x
Yes.
into e to the power y minus 1.
Okay. So basically, we'll be able to find dy dx is nothing but e to the power x, and this is we are having on the other side, and here we'll be able to write everything whatever is multiplied with dy dx. We can shift it to other side, e to the power y 1 minus e to the power x. Any confusion, Fatima?
No, no.
Okay, now by mistake we will not cancel out anything. We can see for now it is not getting cancelled, right?
Yes, ma'am.
Let's try substituting this over here. Let's see, are we going to get wait, it must cancel. Wait. Okay, let's try substituting it over here. We are having dy by dx plus e to the power y minus x. If we will substitute, dy by dx is e to the power this x e to the power y minus 1. Okay, e to the power y 1 minus e to the power x. Here, if we will add e to the power y minus x over here, that means it is nothing but e to the power y by e to the power x, right? Right,
Yes,
Fatima?
ma'am.
Let's
Yes, ma'am.
try taking out, like try doing simplification. Maybe we will be able to cancel it out. Let's check it. However, we must arrange it over here. No worries. Let's try doing it this way. So we will be having LCM as of e to the power x e to the power y 1 minus e to the power x, right, Fatima?
Yes, ma'am.
Okay, and in numerator we'll be having e to the power x is already there, one more e to the power x will come. That means e to the power x square. That means e to the power 2x can be right.
Yes, ma'am.
Okay, e to the power y minus 1, and for the other one it will be e to the power y is there. One more, like this complete term will get multiplied with that numerator, right?
Yes, ma'am.
So we can write e to the power 2y, right?
Yes.
Into 1 minus e to the power x. Any confusion so far, Fatima?
No, ma'am.
Okay, let's open the bracket. So e to the power 2x is there, e to the power 2 minus e to the power 2x plus e to the power 2y minus e to the power 2y into e to the power x. Okay, we are missing something, or let me check the question. This is what we are having. If here only we will expand it. We'll be getting e to the power x as it is, e to the power y as it is, and here we'll be having first function derivative of second function plus second function. Let me check it first. Okay, derivative of first function. So dy dx here will be getting dy dx. So dy dx will be getting. Let me check. This will go to other side, and we can take out e to the power dy dx. Same thing we are gonna have. If it will come to this side, we'll be having. Yeah, this is what we have got here. We can also write it as e to the power y minus 1, y minus 1 over e to the power y minus x. We can write one, right? Right?
Yes.
All right, this is also okay. Let me check it on paper. What can be done? Like the steps we have performed over this one. So we are getting e to the power x plus 1 minus e to the power x, and here we are getting to the power y minus e to the power x plus 1. Right, Fatima? Right?